Yeah, it's okay for me recording.
Yes, yes, very good.
Is your presentation loading, Martin? We still can't see anything.
Yes, just a second.
Yeah,
Can you see it now?
It's coming. Yes, now we can see it.
Okay. Yeah. And for the beginning, just to give a context, I will give a very brief, just few minutes overview about Estonia and wooden house producers' capabilities, and then to present 1-2 minute video about it. Just a second. It's not loaded completely yet. I think it. Just a second. So yeah, as mentioned in this short video, then we are biggest wood house producers in the Europe. I mean, then all Estonian wood house producers together, total export volume is around 500 million euros in 1 year. And here is it how it looks comparing to some other countries. And of course, there are very many different types of houses we can deliver, from high-rise buildings, offices, kindergartens, and of course, renovation solutions. So, and now to the main topic, prefab, or as we call it in our company, industrial renovation. Actually, talking about renovation and industrial renovation, it's of course also about everything energy efficiency, but I would say that the main point is to reduce emissions in a longer way, and then to bring the world back to sustainable track. And that's also why it's so massively supported by governments in Europe with taxpayers' money. About Estonian experience with industrial renovation, it started 2017 when student accommodation by Tallinn Technical University was renovated with prefabricated wooden elements, and in a very tight cooperation with scientists from Technical University Tallinn. And after that, one bit smaller 3-story building close to Tallinn was renovated in similar way. And just a second. Yeah. Okay. And then 2022, we started in Estonia with a pilot project where 19 Soviet-era apartment buildings were renovated with prefabricated elements, and it was also supported by EU and Estonian government. And there was chosen 5 different types of most common apartment buildings. And today, all of them are completely renovated, and we can say that it was definitely a success story. And we learned quite a lot during this process. Here we can see more detailed how it works. By every single project and house, it starts with a scanning, laser scanning of existing building, and so will be a point cloud created, and according then to this data, we can design wall elements. It will be then divided into panels, and with this laser scanning, we can figure out the exact locations of windows. We face quite often rather bad construction quality of these houses, and then there's main challenges are actually with this to find out a proper and adequate fixing method and to line windows, because they're not. It's quite different comparing to new buildings. By all those 19 houses in Estonia, also ventilation pipes were integrated into elements. And already requirement was that by every house that also not only facade but also ventilation has to be added with heat recovery and Also roof were insulated and also heating system and staircases as well. And by some of those houses also apartment doors were changed or replaced. Here are then some sample section drawings, how it looks. But yeah, they are not by every house, but by most of them built so that all the load is actually on a bottom element, which is then fixed with steel angles to the foundation or plinth of the house, so that every next element is just connected to the bottom element here, and only from the top side is fixed with some small steel angle, so that there is no need, at least by 5-story building, to fix to the wall every single element with massive or strong steel brackets. It's enough when all the load is on a bottom element. It makes this installation very, very fast and also cost efficient. So, and of course, main advantage by every project where prefabricated elements are used is a time we can save during all the construction process. It's I would say it's many times faster to insulate all the envelope of the house with prefabricated elements. It takes only a few weeks to cover with elements one 5-story building with 60 apartments. According to our experience, it takes, let's say, some 15 to 20 days, and it's outside complete ready. And of course, using that method, there is no need to move out people from their apartments. And it means that there are much less disturbing of the process, and no scaffoldings are needed. So, and our next video that we call it how to renovate a 5-story building in 20 seconds. I can see it here. On a time-lapse video. And of course, one big advantage is that it's possible to install the elements almost by every weather conditions, even in cold winter time. Yeah, actually it took, of course, a bit more than 20 seconds. It took about 20 days, but it's still many times faster as in conventional way. Yeah, here are some pictures about the installation process. they are quite typical apartment houses in Tartu, what you can see on those pictures. We renovated, I think, at least five-story apartment houses in Tartu. And here are some before and after pictures. This is a 30 apartment, 5-story building in Middle Estonia. All the renovation with our products took about 10 days only by that project. There is another typical apartment building in South Estonia, close to Tartu. And here are some our references in southern Germany, in Tuttlingen, where we renovated 10 smaller apartment houses last year. Yeah, that was it actually from my side. And then the summer, I would say that prefabricated or industrial renovation is actually the only way to achieve our climate goals. Because when we would continue in traditional way with scaffoldings and doing everything on a site, and it will take more than 100 years. But as we know, then we should be reduce dramatically our emissions in next couple of decades, and we just don't have time for using other methods, and we have to be innovative and use industrialized and more standardized methods. Thank you.
Thank you, Martin. Maybe there is some questions for you in the chat. There's no question right now, but if somebody wants to ask something, just open the microphone.
Yes, Martin, thank you. It was really interesting. Also, I think the prefab approach, you're testing it or even doing it in Estonia. We see it happening in the Netherlands, where I'm from as well. In Belgium, I know. So indeed, it's probably one of the approaches which will be needed in the future. You mentioned specifically for the load-bearing components, you're testing to 5-story buildings. Are you also currently testing higher than 5 buildings? I think in Estonia, a lot of buildings are going up to 9 stories.
Yes, there are even higher ones, but technically today we are ready to go up to 9 stories. We have made together with Tallinn Technical University scientists tests and calculations, and with same method it's possible to renovate 9-story buildings as well. And then another important thing here is are the fire resistance requirements. And then since end of last year, we have in Estonia a new guideline which allows us to use prefabricated elements by up to 9-story buildings, so that it's also legally possible and quite easily doable. at least here in Estonia. But yeah, answer is that up to 9-story buildings, it's doable, no problem. And most probably there will be in next year some 9-story buildings will be renovated in Estonia with prefabricated elements.
Yes, and let's hope that one of this building will be our project pilot building.
Yeah, we hope so.
Yes, exactly.
By the way, those test elements which we installed in that Tartu building, say we will deliver to Ukraine. So they would like to start one similar pilot project, and yeah, they are already waiting for delivery.
All right, very interesting. Maybe also some of our external partners, external to the project, may have some questions, either now or later via email. That's also a possibility.
Yeah, sure.
I was wondering, Martin, what type of contractors and other stakeholders do you normally work with, specifically when going international? Maybe that's also something you could highlight a little bit.
Yeah. According to our experience, when we talk about deep renovation or serial renovation, I mean that when not only facade will be insulated with elements, but also heating system and ventilation system will be renewed, and staircases and some other works have to be like roof, and then our part is only about 1/3 of all this renovation project. It means that in Estonia and also in Germany, we need by every project some partner as main contractor, preferably some construction company which is focused on renovation or knows all these details like no, it's a bit different comparing to building new houses. All this communication with apartment owners and so on. It's quite specific, I would say. So yeah, actually, in every market we need some local partner as a main contractor, and who is then also responsible for all those electricity works or heating and ventilation systems and so on. Yeah. And then we also use contractors for laser scanning. We can, with our engineers, build create the point cloud, or from this point cloud we can create a BIM model. But this measurement works we outsource from partners. Yeah.
All right, I think that's pretty clear. If there are no other questions now directly, your information is on the screen. And I think together with Annika, we can certainly facilitate any further outreach here.
Mm-hmm.
If there are no more further questions, I think we can open the floor, Annika, to our next speaker, Solarstone.
Yes. I hope you are here.
Hello, I'm here.
Yeah.
Can you hear me?
Yes, we can.
Okay.
So let's wait that Martin will cancel his sharing, and then you can share your screen.
Mm-hmm.
Martin, we can still see your screen. No? Very good.
So let me know if you can see.
Yes, we can see now your screen.
Yeah. So good afternoon, everybody. My name is Joel, and I'm the building industry category manager in Solarstone. So yeah, I'm the responsible person regarding building industry related questions. So whatever questions, for example, architects could have to us, or prefab manufacturers, or etc. I a bit changed this subject. I made it so that integrating PV panels in high-rise apartment renovations. And yeah, let's start. Whenever you have a question, feel free to just ask. And yeah. So, who we are. Solarstone, we define ourselves as a advanced roofing material producer. So we're a roofing manufacturer whose roofs also produce electricity. We have several different products, and also we're one of the largest players regarding the building industry, PV panel assembly and production. So we have one of the biggest sites in Europe, which we opened last year. So with this, we are pretty much able to accommodate 6,000 houses per year, and now we're hoping to make this happen. Yeah, how do we make the world a better place? We do it by repurposing existing areas. So whether they're roofs or on some cases, whether the areas are already like parking spaces, we can repurpose them and give them more, so that we would already used up materials or areas. And who are our main contacts are current and future property owners, for example, and also everybody related to the process of building a new house. For example, architects, resale partners, installers, roofers, prefab manufacturers, and so on. So this is our quick timeline of how long we've been active. So overall, this BIPV section is quite young. If, for example, we compare ourselves to the regular maybe roof tile manufacturers, they go back hundreds of years, right? We go back maybe tens, not maybe even so. So, but what we can tell is that in our sector, although it's very young, we are quite experienced. So that we started in 2016. We also had our first customer there. And although all through these years, we have done research and development, new products, and so on, and also installed solar roofs. So in 2021, we had our 500th of roof installed. In 2023, we had our thousands of roofs. And yeah, we intend to grow. So currently, we're active in Estonia and also in the Nordics. So Sweden and Norway as well. And now we are also planning to expand into Central Europe as well. So what are we fixing? What's the problem for us? So we see that the traditional way of installing solar can be more efficient. We see that the traditional way is a bit unattractive. It undermines the architectural design of the house. It has an increased environmental footprint, meaning that we have several layers on the roof, which can be more resilient. It could also mean increased workload regarding project management, because we have several different contractors working on site, and everybody knows that this could be a bit of a headache. And also, it can damage the current roofing material, and it can add significant weight to the building construction. And what is our solution? is adding the panel straight to the buttons. Skip the middle part, so that we would have aesthetic looks and less sections where damage or whatever we don't want could happen. So here is the regular solution, right? We have roofing, we have mounting systems, we have rooftop padded PV panels. Here we skip the roofing material part by having it all 2-in-1. How it works is that we take a standard PV module, and this can be used anywhere. We make it a roofing material, but the same PV modules can be used on the ground or a regular rooftop material, like building. It can be used like here, building applied photovoltaics. What we do is we add here our patented system, so that we call it the click-ons, and by that we make it a roofing material, so that we can tie these two together. Like we have when we have several modules, we can tie them together, and also we can tie them into the patterns. So here is how it looks like in a nutshell. So that this is quite the regular section of a roof. We have here patterns and counter patterns, and with clamps and with the click-on system, we can tie these panels straight to the patterns, and they will have an overlap towards each other, and by that we make it a nice looking roof. Also, the ventilation is part of the design. So when the BIPV industry started, the ventilation was a huge question, because when the solar panels heat up, they're not as efficient anymore. But by having here a ventilation system throughout the side of the roof, we don't have these kind of issues anymore. And what we can say is that the panel effectiveness is pretty much as good as it can be, because we are utilizing already existing solar panels produced by solar panel manufacturers who are best at their job, and we are able to keep them in a cooled way so that they can work efficiently. And also, this same section works pretty much in the same way also on the 90-degree angle. So that it means that it can also be installed vertically, because this is what we did with our Open Lab project last year. So last year on the 10th of February, we went to the KMT Prefab, and we installed 2 PV panels together with flashings to the test rack or the test elements, and yeah, this was to also to test whether, well, we all know that the panels itself, they take on the transportational questions really well. It's like, for example, some of the panels really start their journey across the globe, but they travel in a safe way. Like they're palletized, they're strapped to the pallets, everything is good, right? But now we wanted to test whether we are able to install these panels to the element already, and then they will be transported as a part of a structure to the site, and then would be installed. And we wanted to see if this extra handling, this extra transportation, also this transportation maybe in a different way than they're used to, could negatively impact the panel in any way. So that was our main question regarding this test. Here we can also see quickly how the installation took place. So we had the counter patterns installed, and then we added first row clamps, ventilation, joint flashing to have here another solution as well. And overall, the installation was really smooth. So actually, we we talked through all of the sections beforehand together with KMT, and there were no surprises on site, and everything was really smooth and easy. Here we added the second panel, regular clamps as well, and here is also what we can see a bit of a section here. So we have the first panel here. Here we have our click on framing, and this overlap is click on frame to the panel here, and by this it's a roofing material or in this case a wall material. Then we did the installation on site. On site we added additional panels to the junction points of the wall modules, so that we had you can see that there are two different modules here, and then it was decided that we would install these PV panels on site due to the fact that we had here different wall modules. And also we added here dummy panels. So the dummy panels are pretty much part of our product, and they are a mock-up regarding these active panels. So the dummy panels look similar to the active panels, are with the same thickness, but actually they have an aluminum composite materials inside, meaning that we can cut them into the shape we want also inside. And by that, we were able to cover this section up with solar full roof. And in total, we had then 3 dummy panels, 3 PV panels, and all of the flashings around it to seal it up and to make the tests. Also here, Taltech had sensors regarding temperature and moisture sensitivity as well, so that we would have data points for roughly a year. And in summer 2024, the test subject was taken down, and what were the key takeaways? First of all, the installation process was simple and straightforward. There were no surprises, and also like we didn't have to make this solution somehow like so that we have different products for the wall or anything like that. Everything we saw that should work, plug and play, and it did. And now since we are able to install the panels straight in the prefab site, we have all the good and positive sides of pre-manufacturing, like installation in controlled environment, improved quality control, reduced construction time, minimized labor costs, increased safety, enhanced precision, consistency, meaning that the process is very easily repeatable, reduced waste, positives in logistics and transportation, and also this means lower environmental impact, and also overall these projects can be streamlined. Furthermore, from the Taltech's data points, we saw that the ventilation in our wall module was good. There were no issues with excessive moisture, etc. In terms of temperature performance, the solution was pretty much comparable to whatever is put on the wall. So for the material being photovoltaics doesn't mean that it behaves differently compared to standard materials. And also, once the PV panels were taken down, we tested them ourselves as well with the dedicated machinery. We used QuickSun solar simulator, and we did the solar simulation tests to get all of the electrical parameter measurements. So all of the measurements. I wouldn't go maybe into very detail with this, but what we can tell is that all of these electrical parameters are pretty much like standard in the photovoltaic sector, and we measured them. We did the electroluminance image acquisition and automated optical inspection, And also then we did the high-pot ground continuity and bypass test, and everything passed. So the panels were in good shape. They were not harmed, and worked as they should. So yeah, it demonstrated that this solar full roof system can be installed in the prefab site. It really survives all of this extra handling and transportation in a bit different situation really well, and yeah, we can use it effectively. And also, yeah, since we also installed these one panel and the dummy panels on site, we can also say that, yeah, if we install it directly on site, it also survives and works as it should. Yeah, here we have also some pictures of the solution when we have attached it to the wall. So here we can see that, yeah, these are not related to this specific project, but overall, like we're able to install this solution to the walls quite successfully. This was a project which we made together with KMT Middle School in Viljandimaa, in southern parts of Estonia. Here we made them a solar power station, meaning that they can charge their electric scooters and mobile phones during big breaks. And here we also installed the same product into a logistics center. So, yeah, this was roughly it. Do you have any questions?
Yeah, thanks a lot, Joel. I was wondering specifically in Estonia, of course, with long winters, how these production of vertical panels, because I think that's one of the reasons you install them in this way. How does it compare to rooftop installations, and what does it do to energy usage or decreasing energy of buildings?
Well, yeah, overall, like as we know, Estonia is quite Nordic in sense of how much sunlight we're getting throughout the year. By installing the panels to the wall, we're able to utilize the fact that the panels really need to have the sun to be like perpendicular to them, and by that we're able to utilize the winter and utilize the sun being so low. So by that, yeah, we're able to produce more during the low sun months like November, December, January. So yeah, we're able to utilize it more. Like it still isn't like I wouldn't say that, yeah, we would get as much as from the sun as in June or May or something like that, which are the most high producing months, but still we're able to get something. And also, since we're putting them on a wall, we don't have a lot of issues regarding snow being on top of it and staying on the modules, blocking them. So the modules themselves have glass on top, and with that, the snow will get down really easily.
All right. Yeah, that makes sense indeed, specifically for your locality, and most likely also your neighboring countries.
Absolutely. Also, yeah, I would like to add that usually the solar people also want to have a big big empty space where we don't have like windows or anything like restricting us, right? And for these kind of walls are really nice because we have like an empty canvas, so we can put them there, and then we can quite efficiently fill them up with the panels, meaning that we don't lose like power due to the fact that we would have to build around something or something like that.
And regarding internationalization, like what type of partners are you currently looking for?
Yeah, like you can see here, we are looking for prefab manufacturing sites, factories who would work together with us, because we can show on this sample as well that what we did, that our solution was easily installable. We don't have to do the installation ourselves. We can train the crews inside the factories so that they can do it. Also, like it's possible to make the electrical part and the electrical connections also like inside the brief manufacturing site, so that it means that when the modules are being installed on site, you don't need to have an electrician making all of the connections, because we can do them already beforehand in the factory. So yeah, prefab manufacturing and also real estate developers so that they would know to ask our products from the builders. So yeah, since we are a bit smaller, then yeah, we would love to work together with companies like KMT, who would work with the main contractors and so on. So.
All right, yeah, I see an ecosystem already, of course, existing in Open Lab, possibly also scaling out from this.
Absolutely.
Possible partnerships indeed with KMT and other companies expanding to the Lithuanian and Latvian markets, certainly interesting. Yes, if there are no other questions, do you have your information quickly to show on screen as well? Otherwise, Annika and myself will share this later on in the email follow-up.
Yes.
Mm-hmm. Yeah, I think the follow-up can work. Yeah.
Yes. Okay. Thank you, Joel.
Yeah. Thank you.
Thanks a lot. Last up, I guess, Annika.
Yes. Now we are time for Kasper.
Hello. Hello, my name is Kasper. I am working in Eesti Energia, or Enefit as we're more known outside Estonia. And I will be talking about the modern apartment building electrical system. And I'm working in our company in the R&D department for 2 years now, and working as a product manager. And my main expertise is around energy storage solutions for residential, C&I, and grid scale segment. And this is something that I will be covering today as well. But before I make any presentation, I always want to talk a bit about the disruption in the energy markets. Because there's a reason why we're talking about energy efficiency and things as such today, and why this wasn't that much of a hot topic maybe 10 years ago. One of the reasons is that before 2021, nobody really was talking about energy prices. But after the surge in 2021 and even onwards, it seems that this is more often than not the main conversation of topic when I am involved in some discussions. We saw that in 2021 and 2022, energy prices peaked, and they have returned and come back down, but still the prices that they are today, the average prices is still more than double of what it was before the energy crisis in our area. And this has made people concerned what can they do, how can they be protected against those high prices. But just looking at average monthly Nord Pool prices or the day-ahead prices may not be always the best thing to look at. It's also important to look at volatility. How are the prices changing from day to day? And here we can see that even though the average prices have decreased, the monthly average prices, the volatility is still high. And the volatility is affecting more and more those people, those companies, those apartment buildings that cannot really affect the way that they are consuming electricity. And usually, if we look at the average daily high prices, average low prices, usually the ones that cannot really affect their consumption behaviors are the ones paying the high prices. The ones paying the low prices are the companies, the people who can alter their consumption habits based on electricity prices. Whether they can do something manually, set a timer on their dishwasher to wash the dishes in the nighttime when the prices are cheaper, or use some automated solutions to control their devices that are consuming a lot of electricity, and that being EV chargers, heating system, cooling systems, things like that. And if we look at this graph even further, we see that the spread between the average high and average low is constantly increasing as well, which means that just looking at the average prices that I presented in the first slide, and the average prices is often the thing that is seen in the media as well, usually is not the average for the regular consumer. The regular consumer average price, most often than not, is higher than the market average. And a little bit about the upcoming changes in our electricity market, in the Baltic electricity market, is that all of the connections with the Russian grids are cut, basically cut in February of 2025. And because up until so far, Estonia, Latvia, and Lithuania, we have been synchronized with the Russian grid. And we are desynchronizing from the Russian grid in February and synchronizing ourselves with the Central European grid. That will happen in February. A lot of different transfer lines between countries will be disconnected. Furthermore, starting of next year, or in the beginning of next year, we will introduce a 50-minute balance period for consumers. So that means that there will be a new electricity price for every 50 minutes, which today is on an hourly basis. And both of those things will disrupt our electricity markets quite a bit. And to be honest, I don't believe that anybody knows very well the level of impact this will have on the electricity prices in our area. And so yeah, it is going to be definitely a very, very interesting period to look at the market. So yeah, these are the lines that will be disconnected. And main topic regarding apartment buildings. I think we can all agree, if we think about the modern electricity system in an apartment building, we think of something like that. There's an apartment building, obviously, like there will be solar either installed on the rooftop or integrated with the facades with the help of the previous presenter. If it's a rather new installation, most often than not, a battery will be installed to charge the solar. And with the electrification of our transport sector as well, we kind of assume that there will be a number of EV chargers for the residents to use to charge their electric vehicles with. And while I agree with this image on a high level, there are some intricacies in the Estonian legislation and market that we need to really focus on to understand the challenges of achieving all of this, what we want to achieve with these solutions, to be really to minimize our impact on the environment and also to minimize our cost of electricity. And this comes from two different settlement ways that all of our apartment buildings in Estonia are using today. All of those are using either one or the other. Starting from the left side, which is the more common one, is the individual electricity purchase agreement. This is mostly the most used one in Estonia. This means that every apartment will have its own electricity meter installed by our DSO, our distribution system operator. In Estonia, it is Elektrilevi. And these are the meters that are installed before every apartment to monitor how much the apartment is consuming electricity. This information is forwarded to the electricity seller. They will bill you accordingly. Every apartment has freedom of choice in selecting their DSO tariff. Every apartment has freedom of choice on selecting the company they purchase electricity from and the package that they purchase electricity from. And always with apartment buildings, there are some consumers that do not belong to any apartment. For example, some outdoor lighting, indoor lighting. Some apartment buildings have communal water heating. Then this is on a separate energy meter, common consumption, and always when solar energy is introduced to this project, it is installed under this meter. When batteries are installed, it is installed under this meter. And this is the metering point or the settlement point that everybody uses to bill those consumers. All the electricity that is going through for this apartment through this electricity meter, apartment 2 is paying all of the fees, all of the tariffs that apply when consuming electricity. And a second one is a joint electricity purchase agreement, where there is only one electricity meter installed per entire apartment building that is used to bill the apartment building as a whole. And for the apartment building, and then the apartment building needs to settle and invoice all of those bills separately internally. So they install some electricity meters on their own. They will monitor it to understand how much everybody consumed electricity, and they will handle all the billing internally. So the apartment building will handle the billing internally based on these measurements, and the apartment building association will purchase electricity based on this settlement point. And all of the common consumption and production is separated just like with the previous example. Now looking at those two different electricity purchase agreements separately, we can look at the pros and cons because there's both pros and cons for both systems. The one which is used the most in Estonia, the individual ones that are a lot of pros. The main one being is that it's really simple and easy. Everybody has their own metering point, everybody has their own contract. The billing is automated already between the grid operator and the electricity seller. It is really, really simple to do. Also, the apartment owners have the freedom of choice between who are they purchasing the electricity from, and also which package are they using? Are they using fixed package or Nord Pool package or something else? They have the freedom of choice of doing it simply just by doing it themselves online. But a really, really big drawback for this system is that all of those, all of the solar park and the battery, and usually even EV chargers, are installed under this meter. And this means that if the solar park is producing energy and the apartment is consuming electricity at the same time, then the apartment cannot consume the energy generated by solar directly, because the energy generated by solar is going through this energy meter and going through this energy meter. This means that the apartment, for example, this apartment 3, even if physically the electron from the rooftop is flowing to their apartment, they are paying all of those different fees, the tariffs, just like they would have consumed it from the grid. And from looking at apartment 3's perspective, they have no major difference in consuming from own generated solar park or from the grid. And if apartment owners don't have incentives in putting solar on their roofs, then they're not going to do it, because it doesn't make a difference for them. From the common consumption and production view, this means that all of the electricity that is being produced is basically sold to the grid, that because anything after this energy meter up here is already looked as a grid. And if every apartment building, every apartment has its own electricity meter, then obviously they will have a higher DSO tariff as well, because there are small consumers everywhere. But if you're consuming all of the electricity through just one metering point, this means that you are applied to different category. You can get a cheaper DSO package, that all of the electricity that you are consuming from the grid will be cheaper. So there's already, without even bringing solar and battery into the picture, already just going to this joint electricity purchase agreement, everybody wins by just consuming grid energy because the transfer fees will be cheaper. But moreover, using this logic is that if we have a solar park connected under here, then the apartment number 3 can consume solar energy directly without it going through the commercial metering point, which means that they don't have to pay different transfer tariffs for consuming their own produced energy. And this is the main point of doing it. Furthermore, if apartment buildings can consume a lot of their own produced energy, then they can install more solar panels on their building in order because they have a higher consumption in the same metering point. And if they are if it's considered as a self-use locally, then a higher energy class is possible as well. But the cons of this system, while having a lot of financial pros, the cons is that it's a complex system. handling all of those meters and the metering system and the building system inside the apartment association is complex. They need to figure it out on their own, or they need to find a service partner who can install those meters and create this billing system for this apartment building. And the main drawback which we are hearing from the apartment association is that the entire apartment buildings needs to agree on one electricity contract that they use. Every single apartment's owner in the building needs to agree that we want to use one and single electricity provider, and they need to agree on which electricity package are they using. And I'm sure you've all been in apartment association meetings. It's really difficult to get 50 people to agree, everybody in just one thing. This is the most difficult part of switching over to joint electricity purchase agreement. So actually, what I define as a complete electricity system for an apartment building is not only that we have solar park, not only that we have a battery and EV chargers, but also we have a system set in place that we can manage those assets together. And this means that joint electricity purchase agreement is required to do so. Furthermore, in order to really save on the electricity costs, we need a centralized system that controls all of those assets together, because oftentimes solar and battery can be used together. There are some softwares out there, but there aren't that much of solutions available that can manage their EV charging, the solar park controls and battery controls all in one place. It's just a brand new industry. A lot of companies are working on it, ourselves included. There are little available solutions ready today on the market, but I know a lot of companies are working on it. But having control over your devices means that you have control over your electricity costs. Because control, if we are having a joint metering in an apartment building, and if we are controlling all of those devices together, this means that we can shift the entire load of the battery, of the EV charger, of the apartment building to an hours where the electricity is the cheapest. So that the apartment building is protected against the peak electricity prices, which I mentioned before, that usually when you have no control over your devices, most often and not, you are paying the peak prices. But if you're having control over your devices, then you are able to shift it to hours where it's more cost friendly for you. And with the battery solution, depending on the technical solution, there are backup power opportunities as well. Managing everything, all of those things together enables apartment associations to having a control over their costs, and through incentivizing that, we are minimizing environmental impact as well. So with this presentation, I just want to raise awareness that these are the challenges right now in this segment. So please keep those things in mind when designing, renovating, building apartment buildings, but also really important when legislating, when doing some changes in some laws, for example. We need to figure out how can we reduce those limitations for these apartment buildings. That's everything from my side. I hope I wasn't too technical, which I tend to be in my presentations. But if there are any questions, I'd be glad to answer them.
Thanks a lot, Kaspar. I was wondering, as we see a lot with renovation approaches in Tartu and the wider region, of course, energy prices surged in 2021, and there's some leftover effects. They seem, and also from your graph, to have rebounded to pre-COVID levels or pre-Russian war levels, relatively. How does it impact the value proposition of most of the services you are now offering, as we see that this is really a disincentive for deep energy renovations?
I would like to create one correction that even the average prices are coming down, but the volatility has rebounded up. So just the price difference between the days has rebounded, but still, yeah, the prices, even though not compared to the peak prices, are almost doubled when comparing to pre-energy crisis levels. And I think those high prices is one of the key drivers in renovating the electricity system in all the segments. We're seeing that with the residential apartment building, CNI segment, we see that this is the main driver. Even though companies are more and more having awareness about reducing their CO2 impact, we still see that the main driver in renovating their electricity system, installing solar, better solutions. The main driver is to protect against the high prices, and to not consume the prices at the average high prices, but to try to consume prices when they are average, the low prices in here.
All right, thank you. Indeed, specifically, I see peak demand prices are incredibly high still, almost 3x of pre-war prices, probably even more at some points. Thinking about scaling to these different markets, Latvia, Lithuania, do you have experience there already working in these sectors, partnerships established, or what are you looking for currently?
Right now, we see, especially with this meeting, target focuses on apartment buildings. With apartment buildings, I think the key part is the raising awareness of the issues and whether we can overcome those issues alongside with apartment building associations or with the legislators. We are operating all across Baltics, have been doing it for a number of years already. But my main focus would be to raise awareness, because understanding this metering logic and intricacies, and just understanding how much the apartment building association can save their money just by switching over to a joint purchase package. It's a complicated thing, and apartment buildings in Estonia, which we have interviewed, are not really keen on making that change, because that requires having a meeting, everybody agreeing on it, and it's just a difficult thing for them to do.
I have a question. While making this project, right? How long would you think that this agreement would take time? Like when you were preparing the project, how long should be thought? How long should this take in your opinion?
I think the process itself is not the thing that takes most time. What I've seen is that from the distributor system operator side, Elektrilevi in Estonia, for them to change the setup, it is not that time consuming, but rather the restriction comes from the apartment building association. And they need to send all of those materials in front, arrange a meeting, make a decision. Usually the decision does not come from a single meeting. They need to have another meeting where to specify some details and things like that. And this is the main time constraint. And so I would say it depends on how motivated the apartment building is, or how motivated can we make them to be. And that comes through understanding, I believe.
Okay, thank you.
Okay. Is there any other questions? Probably not. Maybe Thomas, you have some other questions more, no?
No, I think I also worked already with Enefit together in the project, so most of the things discussed here are we are already aware of. Maybe I can ask you, Casper, quickly to share your contact details either here on the slide, if people were to want to follow up beyond the meeting.
I don't think my email is shared on the screen. I think we can share it after the meeting.
Okay, we'll share it after the meeting. Then a quick note to yourself, Joel and Martin, to please share the slides you just shared with Annika and myself, so we can follow up on email and share those. Of course, if you are willing to share those slides, I'm not sure